In this example, we want to use implicit differentiation along with the quotient rule. We're asked to find dy dx for the quantity x cubed equals x plus y divided by x minus y. Okay, well we can do that. We have the tools to do this thing. Let's see. Let's just see how it goes. We know the quotient rule. We know implicit differentiation. So let's take the derivative with respect to x of both sides. Remember one more time, that means that every time we take the derivative across a y, or a derivative of y, we need to tack on an extra y prime. Okay, so let's dive in. Derivative of x cubed is 3x squared equals, okay, on the right we have the quotient rule. Low d high minus high d low over the square and away we go. It's kind of the fun way to remember it. Low d high, so low x minus y, low d high, so derivative of x plus y. Well, the derivative of x is 1, plus the derivative of y is 1 also, but we have to tack on that y prime since we're taking the derivative with respect to x. That's the chain rule. So we have 1 plus y prime for d high, okay, minus high, x plus y, we just cut and paste that, d low, derivative of x minus y, well, 1 minus y prime for the same reasoning. Low d high minus high d low over the square, and away we go, so all over x minus y squared. Okay, well, we're done with the calculus. Everything from here on out is algebra. What are we solving for? Y prime. How do we solve for it? Well, it's algebra at its finest. Let's see what we can do here. Let's bring this x minus y squared up over here with a 3x squared, and then I'm going to FOIL these other two expressions together to get somewhere we can have those y primes a little more easy to work with. Our end goal will be to get everything with a y prime in it on one side of the equation, everything else on the other, and then divide out, leaving y prime by itself. Okay, so this gives us 3x squared, x minus y squared. And then I'll just FOIL these expressions together. So looking at this first expression here, foiling that, we have first x outside plus xy prime, inside minus y, last minus y prime, and now minus parentheses, and I'll FOIL the second expression together. I'm keeping this minus out in front of it to remind us that this negative applies to the whole thing. So I just added it in right there, and I added the parentheses. Okay, so now we FOIL this bit. X, okay, first outside minus xy prime, inside plus y, last minus y prime. Okay, this is good because we can start isolating those y prime terms here. Let's do this. Let's distribute this negative here through to all these terms and just drop these parentheses. So that's going to turn this x goes negative, this xy prime goes positive, this y goes negative, and this y prime goes positive. Okay, from there we have some simplification. Look at this. These y prime terms cancel out. I'll always take some cancellation. Look at this. This x's also cancel out. We can also combine like terms here. The xy primes can get together and the y's can get together. So this is actually coming together quite nicely. On the left we still have the same expression hanging out. 3x squared, x minus y squared. I see a mistake up here. This should have been x minus y quantity squared. Sorry about that. Probably drove some people crazy. And on the right we now have equals, let's see, 2xy prime minus 2y. Okay, and finally, let's just wrap this up all in one step. I'll add this 2y to both sides and then divide by this 2x to solve for y prime. This gives us 3x squared minus xy quantity squared this time, minus, make that plus 2y all over 2x. 2x, that's equal to y prime. Okay, so it's really good to practice these implicit differentiation exercises because they bring so many aspects of our course together, right? So here we just did the quotient rule, And other examples we've done various trigonometric derivatives, the product rule, right? So it's a great way to practice all that we've learned so far in a single problem. So I'd say the more you can practice implicit differentiation, the better off you'll be, and the more you'll find that you're mastering all the stuff leading up to implicit differentiation. So definitely a lot of bang for your buck with these exercises.